This type of question is there in Irodov. There is a block of mass 2m as well as block of mass m. They are connected by string. Okay, both the blocks are attached to the upper and lower ends of the string, and the string is compressed by distance x, which we have to find. It is already compressed by this x and it is tied by a string. The spring is compressed by a distance x from its natural length and is tied by a string. Now what is given is the moment this thread is burned. When the thread is burned, then this block just jumps off. The lower block just jumps off after the thread is burnt. So what is x? That is the question. Take down this question. Better. The string is initially compressed by distance x. The spring is initially compressed by distance x. The spring is initially compressed by distance x and is tied by a string Full stop. After the string is burnt and is tied by a string, after the string is burnt, comma, the lower block just jumps off. After the string is burnt, comma, the lower block just jumps off, O double F. Full stop. Find x. After the string is burnt, the lower block just jumps off. Okay. Then suppose this is the natural length of the string. So try to understand, when it just jumps off, means there has to be an upward force which should at least be equal to mg. What do you say? Without a force at least equal to mg, the lower block cannot go up. Suppose somebody pulls you up and you leave contact with the ground. So your weight is, let us say, 65 kg. So at least there should be an upward force of 65 into g. Only then you will lose contact with the ground. So how it is possible? Upward force, it should come from spring. Spring is the only source. And when spring is applying upward force, that means spring is getting compressed here. When will spring try to get compressed? When it is already stretched. So that means the block must be somewhere here and the spring is already in the stretched form. That means it has gone beyond the natural length. This dotted line I have shown for natural length. This is the natural length. So I know restoring force should be at least equal to mg, because if you read the question carefully, just jumps off. So just jumps off means exactly it is equal to, and remember it stops here, it should stop here. And this is x, of course, which we have to find. Let us say it goes beyond this for a distance x dash. So now when the extension is x dash, this is the restoring force. We know restoring force is equal to how much? K into x dash, where x dash is the extension beyond the natural length. This is the natural length. This is the level indicating natural length of the spring. Is it? Right. Now we will be applying work-energy theorem to this block. Okay? We will be applying work-energy theorem to this. Or you will take complete system, not a problem. We will take the entire system, both the blocks plus spring as a system. Okay? Applying work-energy theorem. Work-energy theorem between this position and this position. So first of all, you see that this block has gained gravitational potential energy because it has gone up. So naturally the spring should have lost elastic potential energy. Yes or no? See, if you think this way, it becomes easy. If you simply write the equation and start solving, it will be difficult. Just see, only two forces are there on this block. Of course, this block remained there itself. Spring is anyway massless. We have to consider only the elastic potential energy of the spring. Here, the block has gravitational potential energy and kinetic energy. So there is no change in kinetic energy. Initially it was at rest, and now also it is at rest at the highest position. So there is a gain and loss of potential energies. Elastic potential energy in the spring and gravitational potential energy in the block. Since the block has gone up, its potential energy has increased. So increase in gravitational potential energy of the block, that is mgh, should be equated to loss in elastic potential energy of the spring. So I'll write it here. So gain in gravitational potential energy should be equal to loss in elastic potential energy, because anyway there is no change in kinetic energy. So here it will be mass is 2m, so mass into g into h. H is